All right, we are in Algebra 1. We are on our brand new unit 12-1, reviewing the properties of exponents. Today is Tuesday, March 12th. And we did skip over a few units because I feel that those are less important, and we're not going to get to everything in Algebra 1 just like normal. It's so much stuff to get through. I choose the important bits. So, what is an exponent? What's maybe another word for exponent? What's your personal definition for exponent? Quiet raised hand. Who has an idea of what an exponent is? I see two hands. Go for it, Gunnar.
So I guess it's 2 to the power of 3.
Oh yeah, so like to the power of. So let's do quotes here. Power of.
It'd be like 3 times 3 times 3. Or 2 times 2 times 2.
Oh yeah, so you're actually saying what this is equal to, and we can do that as well. So this thing is the same thing as doing 2 times 2 times 2. The 3 is counting how many times we are multiplying. Exactly. All right, you can turn in your card, and let me get Classcraft up here and going. So Algebra 1, everyone is present today. Gunnar, you just got your XP, and your card is in. Yeah, so exponent power of. There's an unknown synonym, another word for exponent, and it's called the index. You can put that in quotes. Not many people know that, and I'm not going to quiz you, but it's just another name in case you want it. All right, let's talk about what is happening here. There are two names that you need to know. One of them is this bottom number, the thing that's being multiplied. The thing that's being multiplied, its name, does anyone know its name? No. It's called a base. B-A-S-E, base. And then, of course, the 3 on the top, that's what Gunnar was talking about. That's the power, or the index, or the exponent. There are 3 words that you can use to describe him, maybe even more, but I'm going to call him my exponent. And I'm going to write this a little bit to the left because I ran out of room. Exponent. All right, and then I'm going to be using this word simplify, and it can mean different things depending on what I'm asking for. It can mean one of two things. It can mean get as small as possible, and I'm going to use the quotes here on small. So get as small as possible, and by small I mean nice and condensed, like one number to one power. That would be as small as possible, not a fraction. And the other definition, so that's our first definition, I'll put a 1. That's the first definition. Our second definition is only use positive. So instead of writing out the word positive, I'm just going to write this plus symbol with the circle around it. Only use positive powers. So depending on who you ask, simplify can mean one of those two things. I'm going to be saying simplify today, and I'm going to tell you to write in a certain form, so that's getting it as small as possible. I'm using the first definition all of today. All right, so properties of exponents. We're moving down to this table. This is a very important table. You need to have all of these properties memorized for the rest of your mathematical careers. Probably don't need these properties for the rest of your life. You need them as long as you're in a math class. Super important, and they should have been learned, almost all of them already, so hopefully it's a bit of review. Let's see how much of a review it is. And by the way, when I talk about x, I'm talking about anything. I can be talking about a variable, I can be talking about a number, I can be talking about fish. I don't know what x represents. It's an empty slot representing something. So although it is a variable in this case, it could have been 7. It could have been hearts. I don't care what it was, but right now it's x. What is anything? This x represents anything to the power of 0. Does anyone know what anything to the power of 0 is? Josie. Ooh, good guess. Do you want to try it one more time? Good guess again. You can call on someone else, or you can guess again. All right, who do you want to choose? Yeah, who wants to? Yeah, choose on someone that has their hand raised. You don't want to choose? All right, I'll choose for you. Cohen, go for it. It is indeed 1. All right, Josie, you can still turn in your card. You participated. Thank you, Josie. And Cohen also got in. Cohen, there you are. All right, yeah, anything to the power of 0 is 1. So you write a different example from Mr. Sindall. Do not copy me down. Write a different example. Here's Mr. Sindall's example. 7 to the 0 equals 1. You do a different example. Don't use 7. I'm going to do another example. I'm going to try 1,000 to the power of 0. That's also equal to 1. And I'm going to do another one as well just to show you the variety. I'm going to do negative x. All of that to the power of 0 is also equal to 1. There are 3 examples there. You don't need 3. You need at least one of your own choosing. All right. This is a much less known problem. Anything to the power of a negative number. This n is just some number. We'll say that this guy is just some number. N is some number. Usually it's going to be an integer, but I'll just say some number. The fancy way of saying some number is some constant. If you like to sound nice and proper, constant. So n is a constant. X to the negative n is, and I will do this for us, x to the negative n is 1 over x to the positive n. And then the much less, well, I shouldn't say much less known, but another form of this property, I'm going to write it off to the side, and I want you to copy this one down as well. What if I had 1 over x to the negative n? And this one you can kind of take a guess at it. Does anyone want to try to take a guess at this property? Yeah, Sergio?
The xn?
It is x to the n, indeed. Yeah, you can turn in your card. Thank you, Sergio. Yeah, this property, it basically says if I have a negative power, flip it and make it a positive power. I have this negative power, so I flipped it. It's now x to the n over 1. I flipped it and took the reciprocal, and it's a positive power. Same thing over here. It was x to the negative n over 1. I took the reciprocal, I flipped these two, and then I made it a positive power. It just means flip, make it or multiply by negative 1, essentially. All right. You do your own example. Here's Mr. Sandell's example. I'm going to do 2 of them. My first example is going to be 3 to the negative 2. That's going to be 1 over 3 to the 2. Let me do another one. I'm going to do 1 over 2 to the negative 3. That's equal to 2 to the power of 3. Make your own examples. Do not be using my numbers. These are mine. Get your own. All right. Pencils are starting to not move, which means you are ready to go on to the third property today. And it's this multiplying with same bases. So I know I said x can be anything, but these two anythings are the same anything. So it could be 7 and 7, 2 and 2. As long as this base, that bottom number, is the same, then this property holds. And again, n and m are just some constants. I don't know what they are. I guess they could technically be variables, but for us they're constants. All right, does anyone know this property? Yeah, Jose?
So, equals x n plus m.
It is indeed x to the power of n plus m. Thank you, Jose. You can turn in your card. So when I multiply, I keep the base. It's only that same base, but I add the exponents. I add the powers. All right. I want you guys to make your own example. Here's Mr. Sandell's example. 2 to the power of 3 times 2 to the power of 7 is equal to 2 to the power of 10. I'll do another one. Let's do, I don't know, 7 to the power of negative 1 times 7 to the power of negative 5 is equal to 7 to the power of negative 6. I just add negative 1 and negative 5, I get negative 6. It does work with negative powers as well. So write at least one example. If you want to do more, that definitely shows me that you understand that property a little bit better. All right, I see pencils starting to stop moving, so we're going to move on to our fourth property today. So this one is very similar to the last property. Does anyone know this one? So last time we multiplied and it turned into addition. Now we're going to do the opposite of multiply. We're going to divide. How does that opposite change our property over here? Yeah, Nando, go for it.
X n minus m.
It is x to the power of n minus m. Everyone write it down. It's the opposite. So if this operation was multiply and this operation is divide, that's the inverse operation. So the inverse operation of addition and subtraction also makes sense. All right, so go ahead and make an example for yourself. So my example, my first one is going to look like this. I'm going to do, and again, you have to have the same basis. So 2 to the power of 3 divided by 2 to the power of 1 is going to be equal to 2 to the power of 2, because 3 minus 1 is 2. I'll give you another one. Let's do 7 to the power of 9 over 7 to the power of negative 3. Ooh, that's going to be a fun one. I'm throwing some negatives. I wonder if anyone can do a negative in their example. Well, 9 minus a negative is really 9 plus 3. So this is going to be equal to 7 to the power of 12. Ooh, tricky, tricky. That was a fun example. All right. Doing good so far? Doing good? Question?
Yeah, when it's like negative, I add this way.
Yeah, so if you have a negative 3, it's going to be negative 3 minus a negative. So you're going to have negative 3 plus the 5, which is going to be 2. Yeah, good one. I like all these hard examples. You guys are doing harder examples than I am. All right, our next property. Does anyone know this one? When I have a power to the power, a power to the power. Yeah, Julian.
X n times.
It is indeed x to the power of n times m. We multiply those exponents. Thank you, Julian. You can turn in your card. Yeah, so a power to the power is just multiply. Go ahead and give your guys selves an example. So I'm going to try 3 to the 7, all of that to the power of negative 1. That's going to be 3 to the power of negative 7. Negative 1 times 7 is just negative 7. I'm going to do another example. Let's do, 11 to the power of 2, all of that times to the power of, let's do 3. That's going to be 11 to the power of 6. Use your own numbers, try your own example. If you get confused by your own example, bring it up to the class. We'll talk about it. It'll be fun. We're almost done. Almost done. We have 2 more properties. All right, what I want to do is I want to make a note for these 2 properties on the side of our papers. Do a little curly brace. See how good you can make a curly brace over here on the left-hand side. Both of these are really kind of like distribution. So I'm going to do distribution in air quotes, or I guess actual quotes. Distribution. Distribution. When we have distribution normally, it looks like this. 3 times the power of x plus 1. When we distribute, normally what we would do is we'd say 3 times x, 3 times 1, and you get 3x plus 3. This distribution works much the same. You do not need to copy down that yellow. You do need to copy down the blue. This distribution is going to be the same. So are there any guesses as to what this property is? Yeah, Andres.
Xn times yn.
It is indeed x to the power of n times y to the power of n. I'm distributing this power into both of these variables. All right, you're going to have to be careful now. So before we've been dealing, before this distribution, before these last 2, we've been dealing with the same base, x and x and x and x. All of a sudden, now we're having a y. So these have to be different bases. We're assuming that they are different bases. So in your example, use 2 different numbers. For example, I can do 3 times 2, all of that to the power of 6 is equal to 3 to the power of 6 times 2 to the power of 6. Or you can mix in some variables in there. I can say 3 times x to the power of 2 is equal to 3 to the power of 2 times x to the power of 2. As long as those different, or those numbers inside the parentheses are different, then that is a sufficient example. All right, and our final distribution, our last property. Who wants to do it for us? Go for it, Sergio.
That's x to the power of n divided by y to the power of n.
Yeah, and you said it perfectly. X to the power of n divided by y to the power of n. Just distribute that n to the top and the bottom, to the numerator and the denominator. All right, and finally give yourself at least one example. This is one that always gets students. 1 divided by 3. All of that to the power of 2. That is equal to 1/9. Ooh, I did some simplification in there. I wonder if anyone can catch that. I'm going to give you guys one more example. I'm going to do x over 7 to the power of 3. That is equal to x to the power of 3 divided by 7 to the power of 3. All right, so in this unit, this is the main building block that we're going to be using for the entire unit. So if you don't understand this lesson, definitely ask questions. Yeah, Gunnar, what's going on?
Can you put an exponent on an exponent?
You can put an exponent on an exponent. I think that's how a Google works, where you do like something like 10 to the power of 100 to the power of 100. That means this power right here is huge because this power has a ton of zeros. Yeah, actually, I'm curious about this now. We're going to go on a slight tangent, class. What is a Google? A Google. Google. That's what I'm looking for. A Google is just 1 times 100. So a Googleplex is. How do you find a Googleplex? Let's go to Wikipedia. It's 10 to the 10 to the 100. So yes, you can have powers of powers. That is called a Googleplex. 10 to the 10 to the 100 is a Googleplex. It is a huge number. It's 1 followed by 10 to the 100 zeros, or 1 followed by a Google zeros. A Google is a huge number. All right, fun tangent. All right, and coming back. Good question. I like that question so much, I'm just going to give you XP for it. Coming back here, Gunnar, I'm just going to go ahead and say that was a good question, 100. Good question. All right, we have an example. We actually have a lot of examples. I think we have 9 examples. We have a lot of examples. And we have 2 homework problems tonight. All of these problems are based on the homework. So, I told you how I want to simplify it. Oh boy, and I made a slight error in writing these. I put a parenthesis out front, but I forgot to put a parenthesis out at the end. So each of these is missing a parenthesis. I apologize. Bless you, bless you. Nice. It is a teacher error, but I cut it first. All right, so I want to simplify these 2 numbers, and I want to write it in the form of 7 to the n. So even if I have n as a negative number, that's okay. I want it in this form. We're using that first definition. All right, who can do this for us? Using one of those properties up above. You have to have all those properties down within the next few days, hopefully by tomorrow, if possible. How do I simplify this? We're going to write equals over here on the right-hand side. It's going to be 7 to the power of something. I have to figure out what this something, this n is. It's going to be 7 to what power? Do I add? Do I multiply? Do I subtract? What am I going to do here? I need a quiet raised hand. Help me out. I only see one hand. I need to see more hands. I'm just looking for at least 2 hands because it's our first problem. We don't have the confidence yet, I know. I need one more hand aside from Fernando. One more hand. One more hand. How do I simplify this? Come on, guys. All right, we'll give it to Fernando.
Add the 2 powers.
You do add this, so it's going to be 7 to the power of 8 plus negative 3. I'm going to add 8, and I'm going to add negative 3. I'm just adding these. And this comes from this third property. When I have a power times a base to the same power, or times a similar base times the same base to a different power, you just add them. I know I said that weird, but you're just adding these. Oh, messed that up, whatever. I'm adding these, and I get what, Fernando? 7 to the power of 5. There it is. Box it. Final answer. Thank you, Fernando. All right. Example 2. Very similar to example 1. Who can do this one for us? I'm definitely expecting at least 3 hands here. It's the same property. I see Fernando's hand. I see Gunnar's hand. I see Cohen's hand. I'm still going to pause here to see if anyone else wants to answer it. I see Sergio's hand. Sergio has a nice haircut. Cohen, go for it.
B plus negative 12
Plus 4, and that simplifies to b to the power of? Careful. So negative 12 plus 4. Which one is bigger, the negative or the positive? You had the number right, but negative 8. Yes, there it is. Negative 8. Well done, Cohen. All right. I still feel like I haven't called on everyone. How many people still have cards? Can you guys just show your card, just really briefly? All right, I see you 3. Thank you. I'm going to have all 3 of you get in by the end of the day. All right, so we are on a new property, slightly different. I need to simplify this third example. What am I going to do? I see 1 hand. I see 2 hands. Jessica, go for it. You are going to subtract 5 and 7. So 5 minus 7, I do the top minus the bottom, and that simplifies to 2 to the power of? To negative 2. Thank you very much, Jessica. You are correct. 2 to the power of negative 2 because it's 5 minus 7 in the exponents. Jessica is in. Your card is in. All right. Still have 2 people to call on. All right. If you want to jump ahead, go for it. You can go and finish all 9 examples right now and just start on the homework early if you want. We are on to example 4 now. We're on the back. Ooh, we got some variables now, not numbers. This one's a little bit tricky. Andres is ready to answer.
I have a question.
Oh, you have a question?
I didn't get
That's more of a concern than a question, but yes, thank you for reminding me. Now you should be caught up. All right, we're on example 4. We're on the back. We want our simplification in the form of t to the power of something, some number. Oh, thank you. It's funny because I saw you make a 3-pointer out there. I give you guys hard times, I know. All right. The same property as last time. Who's going to do this one for us? Andres is ready. Jose is ready. Monse, go for it. You're correct, but you're simplifying too fast. Let's go ahead and just use the...
So, -6
minus a negative 2. I like how you said that. Minus a negative 2. And then these double negatives, what's going to happen with those, Monse? Turns to what? Into addition. Yeah, exactly. So 6 plus, or negative 6 plus 2, and then Monse, our final answer? Negative 4. There it is. Thank you, Monse, and thank you, Sergio, for helping her out. Yeah, and I saw Jose over there also doing the same thing. Jose and Sergio helping your classmates. I really appreciate you guys doing that. And then Monse, you are in. All right. All right, we're on example 5. We need to write this in an equivalent form. So now we're starting to get a little bit trickier. Now we're not only using our rules up above, but we are making it a little bit harder. So this one I'm going to do for you guys because you might not have seen it before. But I'm going to keep this first term, 5 to the power of 2. I'm just going to rewrite it, 5 to the power of 2, and I want you to rewrite it as well. But I'm going to rewrite 8 to the power of negative 6 as a fraction. 8 to the power of negative 6, I'm looking at this second rule. That second rule states that I can flip it. Right now it was over 1. I'm going to take the reciprocal. So I'm still multiplying here. That multiplication hasn't changed. I'm still multiplying. I'm going to flip it, take the reciprocal, and now it's now 1 over 8 to the positive 6. And this 5 to the 2 is really 5 to the 2 over 1. I'm going to pause here. Make sure that you understand that step. So from here, I can multiply straight through. Whenever you have multiplying, it's the easiest thing with fractions. Multiply straight through. 5 times negative 1. I'm just multiplying the tops. 5 to the power of 2 times 1 is just 5 to the power of 2. All divided by, well, 1 times 8 to the power of 6 is 8 to the power of 6. There's my answer. That is an equivalent form. There are multiple equivalent forms when you're going to be on Khan Academy. If I hold control, does it... Oh, if I drag and then hold control? No, I have to hold option. That's what it is. All right. All right, so This one is going to be using the distributive property. So I think that's our second to last rule. Who can rewrite this one for us? Who can get rid of this -4, putting it into both of these guys? Who's going to do it? Andres is ready to go. Jose is ready to go. Just 2 people. Cohen is up. We'll give it to Jose.
So 2 to the -12 times 7 to the -14.
Ooh, careful. 7 to the negative.
Oh, 8.
-8. There it is. Yep, there it is. Final answer, box it. And then Jose. Got the sniffles. Yeah, we just distribute that -4. -4 times 3 is a -12. -4 times 2 is a -8. All right, we're moving down to example 7. Very similar. This one has 2 different forms that might show up on Khan Academy. We need to find both of them. All right. I don't care which one you find. If you find one answer, that's good enough for Mr. Sandell. Who can find an equivalent form here? Very similar to example 6. Whoa. I don't want you, Adobe Creative Cloud. Trying to make me buy their stuff. I see 1 hand. I need at least 5 hands. I permanently will wait for 5 hands. I only see 1 hand right now. It's very similar to example 6. That's why I'm going to wait for 5 hands. Yeah, you can. Yeah, put it on the bottom. I see 4 hands. I see Fernando, Andres, Cohen, and Gunnar, and 5 hands with Monse. We'll give it to Gunnar. So this -3 you're going to distribute. Yeah, what's -3 times that other one? It is 24. Is it positive or -24? It is indeed. So we have x to the power of positive 24, then what? -12. There it is. Yeah, thank you, Gunnar. That is one of the equivalent forms that I'm looking for. Gunnar, you got some XP. I need another equivalent form very similar to example 5. Look at example 5 now. Rewrite this as another form. This is still an equivalent form, but I want another one. I'm greedy like that. I want 2. I see Fernando has a hand. Sergio has a hand. Andres has a hand. Jose has a hand. I want to hear from Fernando. Keep the x to the 24th. Yeah, times 1 over 9 to the positive 12. And then from there, Fernando? Okay.
So it's x to the 24th over 9.
Over 9 to the 12th. Yep, there it is. There is another equivalent form, which you might have to encounter on Khan Academy. All right, we're 2 problems away from being done with the notes. All right. Example 8. Andres, can you hit the door for us, please? All right, example 8. This one is a little bit easier than example 9. Example 9 I would consider to be the harder version of example 8. Yeah, Jenny, go for it.
It would be x to the power of 12.
X to the power of 12.
Over 3 to the power of 21.
3 to the power of 21. Yeah, well said. There it is. Thank you. And have you turned in your card yet? All right, that is definitely worthy of turning in your card. Jenny is in. All right. Does everyone have their cards in? I think we might just be missing one. We're on example 9. We have one person that has an equivalent form. There are two answers. So Gunnar is thinking he has one of them. Cohen has another one. Who else is going to have an equivalent form for example 9? We'll give it to Cohen.
5 to the power of 2 divided by y to the power of
-4. There it is. Thank you, Cohen. That is one of those forms. And we also have another one. This one is, we haven't really seen him before, but we can use his rule. So 5 to the power of 2 divided by y to the power of -4. The trick here is to use this rule that I wrote on the side. This one over here. We're going to be using that one right now. Does anyone want to take a shot at it? I'll give it to the first come, first serve. Otherwise, it's going to go, yeah, Jose. Really careful. So we'll leave actually 5 to the power of 2. We're not going to touch him, but we are going to deal with y to the -4. How can I rewrite y to the power of -4? So you have to be careful. It's not 1 over because this one was on the bottom, so it's now going to be on the top. Yeah. So you can skip steps or you can write it out this way. So you have the right answer. I'm going to give it to you. I'm going to rewrite it in a different way. So this is going to turn into 5 to the power of 2 times 1 over y to the power of -4. I agree that these two things are still the same. I just separated them. I pulled them apart. You're allowed to pull them apart. By pulling them apart, I can now apply the rule to this fraction. Remember, our rule up here stated, if I have 1 over some base to the negative power, put it in the top, put it in the numerator, and keep it a positive power, or turn it into a positive power. So now I'm going to rewrite this and say it's still 5 to the power of 2 over 1, I'm not going to write the 1 though, times, and now this is going to be a y to the positive 4. I took the reciprocal of this second part right here. And there's my new equivalent form that Jose gave us. All right, let me come back, give Jose his XP. That one is a hard one. It's probably the hardest one that I can give you today. Jose, what's up? Okay. Gunnar gets XP for helping. All right. And, oh yeah, I forgot we're doing bounties now, which means Jose also got 10 XP for reporting the good behavior. Oh man, just all the accumulation. All right, any questions? Did I miss any XP? All right, go ahead and write your summaries. What I want in your summaries, any of these rules that you think that you will forget. If you don't think you'll forget a single one of them, then you're a liar. Write the one that you think you will forget the most, or all of them. All of them that you think that you'll forget, just something in your summary. Personally, Mr. Sindel will forget Rule 2. That's the one that I think students forget the most. So if you write nothing else, rewrite the 2 versions of Rule 2. But some of these properties, I need some of those properties in your summary. And that concludes this lesson.